At the outset, I offer my most reverential pronouns at the lotus feet of His Holiness Dr. Sree Sivakumara Mahaswamigalu, Founder President, Sree Siddhalinga Swamigalu, Reverend President, Sree Siddaganga Education Society. Distinguished Chief Guest of today's function, dignitaries on the dais and off the dais, delegates, ladies and gentlemen, a very good morning to one and all. I, Professor R. Sumati, Department of CSE, SIT, feel honored to welcome you all on the occasion of BITE's Best PhD Thesis Award Ceremony 2020. The Board of IT Education Standards is an autonomous body and a non-profit society promoted by the Government of Karnataka in association with educational institutions and IT industries in Karnataka in order to enhance the quality of IT education. Every year, BITES identifies the research scholars and faculty in engineering from electronics communication engineering, computer science engineering, telecommunication engineering, information science engineering, MCA, and other branches of engineering who have worked on IT technologies by identifying the best PhD thesis. At this moment, I proudly mention that every year, 1 or 2 faculty members of our esteemed institution, Siddaganga Institute of Technology, are receiving Best Thesis Award and Jury Award for their outstanding research work since 2008. Also, I would like to thank BITES for providing an opportunity to host the Best PhD Thesis Award Ceremony for the second time at Siddaganga Institute of Technology. So to begin this auspicious occasion, may I now invite Dr. Mallikarjun BC, Associate Professor, Department of Electronics and Telecommunication Engineering, SIT, to invoke the Almighty.
ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರ್ತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ನಿಖಿಲ ನೇತ್ರನೆ ದೇವಿ ಸುತನೆ ನಾಗಭೂಷಣ ಪ್ರಿಯನೇ ನಿಖಿಲ ನೇತ್ರನೆ ದೇವಿ ಸುತನೆ ನಾಗಭೂಷಣ ಪ್ರಿಯನೇ ತಟಿತಟಾಂಕಿತ ಕೋಮಲಾಂಗನೆ ಕರ್ಣಕುಂಡಲಧಾರಣೆ ತಟಿತಟಾಂಕಿತ ಕೋಮಲಾಂಗನೆ ಕರ್ಣಕುಂಡಲಧಾರಣೆ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ವಿದ್ಯ ಪ್ರದಾಯಕ ಶರಣು ಪಾರ್ವತಿ ತನಯ ಮೂರ್ತಿ ಶರಣು ಮೂಷಿಕ ವಾಹನ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ ಶರಣು ಸಿದ್ಧಿ ವಿನಾಯಕ.
Thank you, Dr. Mallikarjun. May I now request Dr. S.P. Dinesh, Principal, SIT, to formally welcome the Chief Guest and other dignitaries of today's function.
At the outset, I submit my respectful pranams at the holy feet of His Holiness Sree Sivakumara Swamiji and Sree Siddaganga Swamiji of Siddaganga Mutt. Dignitaries on the dais and after the dais, invitees, ladies and gentlemen, very good morning to all of you and hearty greetings from SIT TUMKUR. The Board of IT Education Standards, popularly known as BITES, was established in the year 2000 as mentioned by our Professor Sumati, promoted by the Government of Karnataka in association with the educational institutions and IT industries. This board is continuously striving to promote IT education at par with global IT standards. The objective is to make Karnataka the preferred destination for IT. Among the many objectives, BITES encourages faculty and research scholars involved in quality research by instituting BITE's Best Thesis Awards in the IT areas. This year, SIT is hosting BITE's Best PhD Thesis Awards 2020 award ceremony, thanks to the chairman, Professor Murthy, and board members of BITES. We invited Professor Raghavendra Prasad B, Senior Professor, Indian Institute of Astrophysics, Bangalore, as chief guest for this award ceremony. He was kind enough to accept our invitation and present in this occasion. I extend a very hearty welcome to Professor Raghavendra Prasad. Hearty welcome to you, sir. I request you to kindly accept the bouquet. We also invited Professor G. Jagadish, Chairman, Center of Excellence in Hypersonic and Professor of Aerodynamics, Indian Institute of Science, Bangalore, as guest of honor. So he accepted our invitation and is present here. I extend a hearty welcome to Professor G. Jagadish. It gives me great pleasure to extend hearty welcome to our SIT's well-wisher, Professor K.N.B. Murthy sir, Chairman BITES, Vice Chancellor, Dayanand Sagar University, Bangalore. Hearty welcome to you, sir. I extend hearty welcome to Professor M.N. Channabasappa, Director SIT and Board Member BITES. Hearty welcome to you, sir. I also extend hearty welcome to Professor Sivakumara, CEO SIT. Hearty welcome to you, sir. Friends, the central point of today's award ceremony are the best thesis awardees and special mention of the jury awardees. Dr. Kirti Srinivas Shetty, Tribal IT Hyderabad, and Dr. Puneet Kumar TR, SIT TUMKUR, are the best thesis awardees under Computer Science and Electronics and Communication category respectively. I extend hearty welcome to both Dr. Kirti Srinivas Shetty and Dr. Puneet Kumar TR. Hearty welcome to both of you. Dr. Samina Begum Patan, MIT Mahe, Manipal, and Dr. Rupa S. SIT Tumkur, and Dr. Gran Joktan D. Mello, NMIT NITE, are selected for special mention of the jury awards under Computer Science, ECE, and other branches category. I extend cordial welcome to Dr. Samina Begum Patan, Dr. Rupa S., and Dr. Gran Joktan D. Mello. Hearty welcome to all of you, sirs. Friends, BITES appreciates the efforts of research supervisors in performing quality research leading to the selection of best thesis. The research supervisors will also be honored on this occasion. It gives me immense pleasure to extend hearty welcome to Dr. Annappa and Dr. Krishnamurthy K. from NITK Suratkal, Dr. P.C. Siddaganga Swami from MIT Manipal, Dr. Narsimhan S.V. from NL, and Dr. Srinivas Pai P. from NMIT NITE. Hearty welcome to all of you, sir. I also extend hearty welcome to Dr. D.N. Sujata, Executive Director BITES. I extend hearty welcome to all the board members of BITES. I extend hearty welcome to the jury member, Professor Shyam Vasudev Rao. Hearty welcome to you, sir. Hearty welcome to Dr. S.S. Katte for providing technical support for the award ceremony. Extend hearty welcome to all the invitees, heads of departments, faculty and staff members. I also extend cordial welcome to all those attending this function in virtual mode. Thank you all. Thank you.
I take this opportunity to welcome Krishna Swami Subbarao from Infosys. It's my privilege to formally welcome Principal Dr. S.V. Dinesh on behalf of BITES and the institution. I welcome you, sir. Ladies and gentlemen, knowledge removes ignorance just as light removes darkness. Knowledge is a lasting inner wealth by which all our achievements can be accomplished. Hence, we light the lamp in reverence to knowledge as the greatest of all the forms of wealth. May I now request honorable dignitaries on the dais to inaugurate the BITES Best PhD Thesis Award Ceremony 2020 by lighting the lamp. Thank you, one and all. May I now request Dr. K.N.B. Murthy, Chairman, BITES and Vice Chancellor, Dayanand Sagar University, to make the opening remarks.
Good morning. I submit my pranams to Sree Sivakumara Swamiji and Sree Siddaganga Swamiji. I'm extremely happy to be a part of this event. The respected dignitaries on the dais and off the dais, we are happy that event which was to be held long back is finally happening today. I think we got it. We wanted to have this particular function physically, therefore we had to delay this because of the pandemic reasons. And we also have a custom that we would organize a function in an institute wherein one of their faculty is a recipient of this award, which we have been doing it since from the beginning. I'm also happy that SIT TUMKUR has kindly agreed to host this function. On behalf of BITES and all the board members, I would like to thank SIT for being a host institution for this function. We are very fortunate to have Dr. Raghavendra Prasad, the senior professor of Indian Institute of Astrophysics, to be the chief guest for this function. He is an accomplished researcher. Obviously, he is going to address all of us and tell us more about the kind of research that's happening in this institution, what constitutes high quality research, and some other things. We are equally happy that Professor Jagdish Gopalan and others, the other members of the jury panel, are here to be a part of this event. I would like to take this opportunity to congratulate all the winners and also thank them for making time of their busy schedules to be with us this morning. First, Professor Jagdish would talk about the process that's been followed, how exactly we arrived at this list of winners, and possibly would know more about the kind of quality of thesis that we have received, how did we go about doing that, etc. As you're aware, Board for IT Education Standards is an autonomous body started in the year 2000, and this organization has been doing its best to conduct several activities. However, the primary objective of this organization was to improve the employability of the IT graduates. That's the objective with which it started. However, this also has an eminent governing board consisting of about 18 members, 3 from the government, 6 from industry, and 5 from academia. 4 are the invited members. It has a very powerful board. One of the events that we conduct annually as far as the BITES is concerned is the Best PhD Thesis Awards. Initially it was restricted to the faculty of member institutions. In the last few years, based on the recommendations of the board, we have extended it to the faculty and research scholars of all the engineering institutions in the state of Karnataka. We also conduct several activities like the celebrities and celebration lectures, then student project competitions, several hands-on workshops on the recent topics, the relevant topics of importance. We also started conducting several distinguished guest lecturers in the recent past. We really don't know what kind of impacts this pandemic has made to various sections of the society, sections of the people. As far BITES is concerned, I can tell you very honestly that it came out as a boon for us because we could conduct a lot more activities than what we were doing in the past. Because organizing a physical activity is always difficult, but organizing a virtual mode of lectures, virtual mode of events is much easier. We also instituted several other programs like BITES Lifetime Achievement Awards and several things. Today I can say confidently that BITES has established credibility in the academic community. At least has been seen with a lot more respect, lot more passion than what we had in the past. After I took over as the chairman of BITES, I started tracking how much of impact the BITES activities have been making on the community. Because I would like to check whether there's any improvements that we have done, what else that we can plan it out so that the community stands to benefit from whatever we are going to do. I am very happy to inform the chief guest and others here. Roughly after I started tracking it, after I took over as the chairman in 2017, we have completed close to about 246 weeks all put together after I took over as the chairman. Because I wanted to make a clear-cut analysis, are we making any impact on the stakeholders. Close to about 344 activities have been organized, about 1+ activity per week. Secondly, we could reach out to 27,031 participants, including the activity that we had yesterday evening. That was a lecture by Professor Y. Narahari. At an average participation of about 82.36. It means every activity of BITES has been attracting good number of stakeholders to be a part of that. It clearly means that we are making some impact in the academic community. Coming to the function that we have been organizing today, BITES Best PhD Thesis Awards. This is a 9th edition of the program. Though it started in 2008, we have conducted 9 events. Mainly because in some of the years we did not get enough thesis for evaluation. Therefore, we had to combine the thesis of 2 years and make the evaluation. 2010 and 11, we had to combine. 12-13, we could combine. 14-15, again we had to combine. 16-17, we had combined. Mainly because we did not receive good number of theses, the response was slightly poor. From 2018 onwards, we see a surge of submissions. Professor Jagdish would tell us more about the number of theses that we have received for this year. At least 20+ theses have been received every year. I think this year has been the maximum, where we received about 37, and that was the highest so far. And you also know that submission of thesis is not the end of. We going to look at every aspect of it before we take it for evaluation. Another interesting statistic also. So far, in the 9th editions, the work of about 30 research community has been recognized. 30 people have been recognized. 15 from E&C, Electronics and Communication, 14 from Computer Science, 1 from Others category. I'm also happy to tell you that the Best Thesis Awards are about 20, 10 are the special mention of the jury. Basically, we recognize some of the good theses which did not qualify or did not make it to the final, this winning. That particular, again, thanks to Professor Jagdish, who has been pushing the amendments to be made for everything that we have been doing in BITES. I see Professor Jagdish and Professor Prabhu. I think both of them push the organization to look forward and see what best can be done. Again, very interesting thing. Out of 30 awards that have been given by BITES, 7 are from SIT TUMKUR, topping the entire Karnataka state. SIT TUMKUR has received a maximum number, 7 awards, out of which 6 are in the E&C category, 1 in Computer Science. Out of 6 in E&C, 1 was special mention of the jury, the remaining 5 are Best Thesis Awards. More or less, Electronics and Communication is the home ground, is always SIT TUMKUR. That's what it appears. Manipal Institute of Technology has bagged 6, RVCE 2, SJC Mysore 2, PS University and PSIT 2, NITK Suratkal 2, BVBG College Hubli 1, Rewa University 1, CMRIT 1, RNSIT 1, Sharanabasava University 1, Jyoti Institute of Technology 1, SDM College Dharwad 1, then SIT Mangalore 1, NMAM IT Nitte 1. That's how the breakup appears to be. And this recognition, which goes a long way, mainly because this is a kind of the function that we do to motivate the faculty and research scholars, and also tell them that the journey has begun now, and also appreciate the kind of work that's been done. I'm sure the speakers following me would talk more about the good quality research and also the kind of process followed in this. And finally, I would like to thank the organizers for hosting this function, and also thank all the award-winning members for making it to this function. On behalf of BITES, I submit my thanks to one and all to this function. Thank you.
Thank you, sir. May I request Professor G. Jagadish, Chairman, Center of Excellence in Hypersonics, Professor of Aerodynamics, Indian Institute of Science, Bangalore, to brief about the process of evaluation of thesis for award.
Ellargu namaskara. Seeing this august audience, I am reminded of Saint Tyagaraja's famous verses. Indulo Mahanubavudu mi andariki na vandanam. Good afternoon, friends, and it's a very special occasion in the sense long back, in fact, when I was a student, I did approach a very senior professor asking him that I want to do PhD. I will not take the names. And then I asked him out of curiosity, sir, in what topic should I do PhD? Then in a very non-coherent manner he said, you can do PhD in Bhagavad Gita. To be honest, it actually put me off very badly. Because at that point in time, I was like one of you working in a private engineering college after BTech. And I had to join because of my own financial constraints at that point in time. And I had probably traveled about 1,400 kilometers from Bangalore with lot of hopes. And when I went there and I asked, this great man said like, oh my God, he has put me off. I am sure many of you who teach in private engineering colleges who want to do PhD would have gone through this. But then today, friends, I can tell you, yes, I can do PhD in Bhagavad Gita. You can do PhD in Bhagavad Gita. Because PhD is not a degree. Of course, there are several acronyms for PhD as passed with high difficulty, perennial head damage. I am sure these things would float around. But I think PhD is a process of learning how to look at nature, how to ask probably the right question than try to find out what is the right answer. Maybe it makes you a better person. And probably the journey has just begun of looking at things in a different manner and enjoying the entire inquisitive, wonderful nature that is around us. Friends, we are at a very critical crossroads. Before I tell about how did we select the PhD thesis, I'll just take 2 minutes. Why this is extremely critical for many of us, especially teachers, is that the amount of disruptions that you are seeing in our day-to-day life and the way the whole technological space is evolving in the last probably 5 to 10 years, this world has not seen in the last 300 years. I don't know how many of you are keeping track of what has actually happened in 2022. It's not even 4 months into 2022. Oxford University has announced the first successful demonstration in the laboratory of nuclear fusion. A person who had AIDS has been cured completely. Human genome has been sequenced in a time frame of about 3.5 hours. Simply mind-boggling. We are all fortunate to be there at this stage. But pandemic has also put a death nail into the way we teach in the classrooms. Teachers are no longer required in the classroom to pass on information. Information is available in plenty with the students. You have NPTEL to Coursera to I don't know what not today. Which means teaching profession itself is being questioned today at several places. People believe teachers are no longer required. I think the only way we can survive and enjoy this journey is if we can convert that information into knowledge and teach the students how to gain wisdom out of that knowledge. PhD is a wonderful process which basically helps you to synthesize knowledge from the available information, and you become wiser so that your interaction with students in the classroom would become much better. I think in that sense, every one of us should continue to do not just one PhD, several PhDs in our life. And that is why the publications are one of the means by which you continue to do that. Not because somebody will give you promotion, not because somebody will probably recognize you with an award, but the very fact of finding answer to your unknown question is the greatest satisfaction a teacher can ever get. That asking question why, to me, is probably one of the fundamental tenets of a teacher, a researcher, a scientist. And you ask the students, hey, why don't you ask questions? But you never ask questions to your own self. And it is that inner journey is what you call probably as a spirituality. Maybe the outer journey of understanding, the nature would become science. So in that context, I am so glad that every one of you who is present here or not present here who thought that I will apply my thesis as a nomination to this best PhD award, I think all of you are winners. First of all, we should believe that our work is good enough. If I am satisfied with my lecture, my thought process, my interactions with the students, obviously students also would enjoy. I have been associated with BITES probably now more than a decade, and it looks like a one-way traffic. I was roped in by somebody, but I am not able to get out. But I have been enjoying every bit of this journey with this organization. And almost in the Best Thesis Award, along with Professor Sonde, who is no more, I have been around now, I think, for the last 12 years. One thing I can very clearly say that year after year, the quality of thesis has shot up. This is something which is very, very heartening to note. And the amount of time that the jury has to spend in reading the thesis has also shot up. And please again, let me correct that we are nobody to evaluate your PhD thesis. We are just trying to figure out whether among the thesis submitted, can we actually recognize few to give an award. Because evaluation of your thesis has already been done, you have been awarded PhD. So please don't get us wrong by saying, I am no expert to really say whether the thesis deserves a PhD, because so many fields are there. All that we have tried to do is see whether there is any extra spark. Is there any novelty? In fact, the motivation to me is the most important chapter in a PhD thesis. Because you search the literature and then you say, can I come out with some 3 or 4 questions for which I can find answers? Maybe the process of finding answers to those 3 questions, you may probably end up with another 20 questions. So the scope of future work that you write in the last chapter, again for me, is most important. If you started off with 2 questions and that now you are not able to answer even half the question, means it is a fantastic area to pursue. And your most productive years, friends, please believe me, it will be after you submit the PhD thesis. At least I have experience, I am sure Prasad would vouch for it. My postdoctoral stint in Tohoku was probably the most enjoyable part, because that is the time where your PhD thesis, I am sure all of you would agree, it gets done in the last 6 to 8 months, correct? All the other thing is actually preparatory. At that time, you will be in full concentration, your mind will be very focused, and being teachers and trying to do PhD is even difficult. You have your household, and I know how tough it is. 30 units you have to teach, you have to value blue books, you have to do all the other things, because I have gone through that. But that part of the journey is very fascinating, but please don't stop and start, publishing further. So this year, before I forget, my special thanks to our jury members. Dr. Sham is here, then Dr. Sunita and Dr. Prakash. They all did a fabulous job of going through every one of the theses. And we looked at the novelty, we looked at the publications, we looked at the patents, we also went through some of the papers. It is so I'm so happy, I'm filled with joy to say that people from even institutions which are not supposed to be very elite are able to publish in journals like IEEE letters is a remarkable achievement. I could see the quality of publication among all the people who submitted has just shot up. And we introduced even other branches of engineering could actually submit the thesis, like mechanical. I think this year also there is a recognition where people from engineering, mechanical engineering, are able to use advanced neural network to look at surface roughness. IT, in some sense today, has become a part and parcel of all our life. I do believe that maybe in 5 years' time, computer science may not really remain as a separate branch of engineering, because it has become part and parcel of every branch of engineering. What I would urge SIT people is, please do not close down your mechanical, civil, electrical branches, because they are the foundations on which the next generation economy would take off. So this slight lull in the admission is a temporary phenomenon. Industrial AI and data fusion is actually coming up in such a large force. People with domain expertise and knowledge in respective computer science domain in general, they are in big demand in the industry. So just to wrap up this, the jury basically went through all the PhD theses, and then we were able to arrive at our own conclusions. We have had series of meetings, and it was extremely hard to pick up a winner. And special mention jury, I think there will be more than 15 worthy winners. And I have, I'm telling this with the bottom of my heart. Many of the theses that we read were much better than the PhD thesis I wrote up maybe 30 years ago. Without any, I'm not saying this just for making a statement, because I could see a lot of innovativeness. Maybe they have gone out of their comfort zone. They have used advanced diagnostics. One of the very nice features that I saw in this year's PhD thesis was a lot of people have started using analytical method. Professor Chennabasappa would be very happy because mathematics is the foundation of engineering. And people think mathematics means some differential equation and they never really connect that to physics. For anything and everything, people want to use a numerical method today. But we did see some of the PhD theses which have actually used analytical method, classical methodology of trying to solve problems. And many of them have done experiments, numerical simulation, and many of the problems, including the image processing where you're looking at a medical diagnostics. Again, the candidates have gone out of their comfort zone and interacted with hospital. I think from Mahia, you had such a wonderful thesis on liver cancer or lung cancer, I suppose, one of them. Huh? Skin. So this is very nice that where people have looked at realistic problem and how to solve them. So all of you are winners, and special thanks to the guides, because normally people don't really think guide is very important, but guide is extremely important because he himself is going to be under tremendous pressure of his own teaching, but they also make sure that they work along with the students to guide. And guide or guru is very important. I am always reminded of what Kuempu said in Shatamanada Sandhi ಅಂತೇಳಿ ಬಹಳ ಒಳ್ಳೆ ಕವನ ಸಂಕಲನ ಇದೆ. ಅಂದು ಹಿಂದೆ ಗುರುವಿದ್ದ ಮುಂದೆ ಗುರಿಯಿತ್ತು ಸಾಗುತ್ತಿತ್ತು ರಣವೀರರ ದಂಡು, ಇಂದು ಹಿಂದೆ ಗುರುವಿಲ್ಲ ಮುಂದೆ ಗುರಿಯೂ ಇಲ್ಲ ಸಾಗುತ್ತಿದೆ ರಣಹೇಡಿಗಳ ಹಿಂಡು ಅಂತ ಹೇಳ್ತಾರೆ. That was probably coined during the time when India had just become independent and Karnataka state had not yet formed. And he in fact appreciates J.H. Patel for speaking in Kannada for the first time in Lok Sabha in those days. I just raised it to highlight the role played by guides here. Thank you very much, and hearty congratulations to all the winners. And if some of you have not made it, please by no means think that your thesis were inferior or anything. It is just that there were few awards, few recognitions, and I am sure that if you continue to do good work, and it's going to be recognized sometime in the near future. But a word of caution for people who are being recognized, please make sure that at least you guide a couple of more PhDs, and your students should win award on these forums. And that is the only way. When your students do much better than you, that is the ultimate fulfillment for any teacher. Thank you very much to all the SIT people for organizing this award function, and hearty congratulations to winners once again. Special thanks to all the jury members and Dr. Katte especially, who made our life so easy, and Jyoti madam, and all the other people in Bytes who actually made this entire process very enjoyable. And I am sure that from year after year we will have better PhD thesis. Let us enjoy doing science. Let us enjoy teaching. Let us enjoy producing worthy citizens of this great nation, India. Thank you very much.
Thank you, sir, for highlighting the importance of PhD, core branches of engineering, factors considered in evaluating the thesis. Thank you very much, sir. So, ladies and gentlemen, now I take this opportunity to introduce today's chief guest, Dr. Raghavendra Prasad B. Dr. Raghavendra Prasad B is currently Senior Professor at Indian Institute of Astrophysics, IIAP, Bangalore. He worked for IIAP for over 23 years. He works in the area of adaptive optics and space science instrumentation. He has been heading some major science projects in addition to teaching and research. He authored several research papers in high-quality journals and conferences. He has obtained his PhD from Indian Institute of Science in Nonlinear Optics. With this brief introduction, may I request Dr. Raghvendra Prasad B to address the gathering on this occasion.
I'm sorry for this disruption. Very sorry, sir. I'm very sorry.
offer my prayerful salutations to the great founders of this august institution, Sri Sivakumara Swamiji and Sri Siddaganga Swamiji. And then, of course, I was, I never thought I'll meet Professor Chandra. And when Professor Jagdish was telling me about him, and I mean, that's the passion and commitment based on which this institution is really, really moving forward. And of course, rest of the faculty members and Professor Murthy and of course, Professor Jagdish has been my good friend for last many years, and then probably we share some common interests in various aspects. And I thank all of you for giving me this opportunity. And first and foremost, my heartiest congratulations to all the award winners and those who submitted their theses and various things. And the jury members, I'm sure I know how hard it is to be a jury and finally pick up the so-called quote unquote the best thesis. It could be really, really hard. And I'm sure, knowing the composition of the jury, I'm very, very confident that they have done a really, really hard work. And those there are always winners and others are not losers. Maybe little less, fortunate. That's it. But otherwise, I think it's as Professor Jagdish talked, and it's everybody is a winner because we also went through this phase of being students and doing PhD and trying to be recognized by various organizations. Like personally, I myself went through this process by Optical Society of India, Laser Association of India, various organizations, and I know how it feels when you're being called and given these awards. And at the same time, I remember many of the jury members telling others to, really not to lose heart and move forward and keep the spirit up. And as I see my own contemporaries, many of them have done extraordinarily well in the domain of research. And in fact, Professor Jagdish made my life very simple today. Okay? And I mean, it's a phenomenal talk by him, phenomenal, inspiring, advice to all the researchers and students and everybody. And of course, my own life began at after my masters. I joined University of Science. Those days, selection process in University of Science was very, very difficult. Actually, somehow, I mean, I did not know. I was grilled for almost about 6 hours before I was taken in. And then I joined. I was fortunate to join Professor P.S. Narayanan, who was the last student of Professor C.V. Raman. And that was the best thing that could happen to me when I joined for my research. He was such a wonderful gentleman and such a serious scientist. And then the kind of interactions I had with him, and it was really, I mean, amazing and mind-boggling. The next best person whom I can recall as my own, who sort of shaped my own career is, I should mention his name. I'm sure most of you are familiar with him. Is Professor K.P.J. Reddy. Because we had a joint program called Laser Applications Program. And then I was in physics department, he was in faculty at aerospace, and we were working on some of the projects like gas dynamic lasers and gas discharge lasers and various things. And of course, non-linear optics and various defense applications. And then he would tell me, Nodi Prasad, now ಏನು ಮಾಡಿದ್ರು ಕೂಡ ಕೊನೆಗೆ ಬೇರೆಯವರಿಗೆ ಏನು ಉಪಯೋಗ ಆಗುತ್ತೆ ಅಂತ ನೋಡಬೇಕು. Just don't look for publications. Make sure that whatever you contribute is of some use for larger population, and particularly the what I'm saying, not so very fortunate ones in the society. So that really shaped my future program. What I want to do personally, and wherever I am, possibly I will think of how to look for spin-offs. Okay. And that's when I decided to move from pure sciences to applied physics, and finally I ended up in the Institute of Astrophysics. And I mean, I have had an extraordinary journey over there, and I'm still enjoying my work over there. So today I'll be addressing, because I'm sure astronomy is some domain most of you probably would not have been exposed, and the kind of challenges we face there, okay, in terms of realization of what I call observation platforms or tools, be it ground-based or space-based. And it's really an engineering challenge. I mean, we have been working on several projects for several years. We still see that, we are nowhere near to the end. I mean, it doesn't mean that we don't want to end it, but we want to look for some kind of perfection and make sure that things work as planned. So that's where we have, in my own group for that matter, currently we have 28 people. Out of that, 24 are engineers. Okay, and 4 are, faculty members. And so that's the level of engineering requirement that I personally have in this. I will just talk about that particular project in a few minutes later. Could we go to the next slide, please? Yeah, I will sort of give a brief, introduction to astronomy, because astronomy is a subject which, of course, there are people who understand what it is, and there are also people who mistake that with astrology. Okay. And that's a very common, in fact, we had those problems actually. Several people, trying to tell us, even personally, I had many such, requests. It's like, look at horoscope, look at matching, and whether we have somebody in my institute who can do that. And believe it or not, it was there even from the ministry side long time ago. I don't want to take names again here, okay? There was pressure to institute astrology, but let me tell you that there is a domain now which is called archaeoastronomy, okay? Archaeoastronomy, which is an interdisciplinary thing which looks at ancient traditions in astronomy, how astrology came in. It's a science by itself now. There are some groups which are now trying to go more deeper into it. Probably after my retirement I will do that, but right now I have no time for it, okay? Okay. Now, again, what is that we are trying to do in astronomy? What is it that we want to understand? What is it we are looking for? What are the tools? I mean, we simply say light is a tool over here, okay? What does it mean? But how do we, pick up this, what is called every photon, what we call as cosmic messenger, okay? So our idea is to build instruments or telescopes or back science instruments which we can pick up the very first photon which has originated at the start of the universe. Okay, now can we say that there are evidence to say that before this Big Bang theory, there's one more, universe, what we call as by CMBR experiments. We have known that there was a universe already. We are able to measure those remnants of those earlier universe even before this universe came into existence. So there are a lot of such challenges over here. So what is most important is for us is to pick up every cosmic messenger that comes from the first epoch. Okay, and then what happens in between? How did the life, originate on Earth, or are there any other intelligences in the universe? How do we look for those signatures? See, everything has to be. I mean, it sounds very romantic, all right, but when you really want to implement, when you want to find, say, how do I find life outside? Okay, it's a simple question. A lot of people ask that. What are the signatures I'm looking at? How convincing is it? Is it the right signature I'm trying to use for finding the life? Are there any other signatures? Okay, so these are all the real challenges. Okay, I'll just probably touch upon some of them, and mostly I'll focus on the engineering challenges because the community is more of engineering over here. And what is most important here in in this engineering challenge in astronomy particularly is the real passion. I will tell you have 90% failure, 10% success. So the passion and perseverance is the most important thing over here. If that is not there, I suggest people should not venture into it. But once you get into that, in spite of failure, you want to move forward for the success, because what I would say, to use a very loose term over here, we use in the kind of inspiration you get or kick you get out of it, what the students parlance, is something which is enormous. Okay, so next slide, please. Okay. Now, typically, how do we approach? I'll just come across some projects. See, astronomy community in India is very small. Probably no matter how you count, not more than 100 astronomers will be there, okay? The real serious astronomers. Of course, there are many interdisciplinary astronomers and things like that. Now, the budget for astronomy, okay? The government of India budget for astronomy is about a couple of thousand crores per year, okay? Now, why is it so much? Why are we spending so much money? What is so great about it? Why are we blowing up taxpayers' money? These are very standard questions. Not only people ask, even the government asks us, because we are accountable, okay? So we start with some real science goals, which ultimately end up with technology spin-offs, okay? That's something which we try to always connect, okay? And once we have very clear science goals, what can be done, what cannot be done, what we want to look at, of course, there are many unknowns. We don't know whether they are part of our science goals, or we sort of find them as we travel along. Okay, that also happens many a times. So, but once we have these basic science goals and whether it can be done, see one example, we want one science goal I am talking about is just to give you something. I want to measure the space, I want to predict space weather challenges. Okay, it's a very important, issue now in trying to sort of maintain our space assets as well as communication grids and various things, solar storms, what we call. So now that is my science goal, okay? Now to measure that and have a predictive model at the end of the day, what do I do? How do I go about that, okay? So then we have what is called a very strong systems engineering group where we have engineers from mechanical, computer science and optics, you name it, including civil engineers, okay? We have multidisciplinary systems engineering group with whom people like me, because I link between science program plus the engineering challenges, okay? With them, I interact with them very hard, okay? To turn the science parameters into engineering parameters, which can be realized. Most of the time they say, no, you're asking something nonsense, we cannot realize it. Okay, so you have to sort of work with them day in and out and ensure that we come out with an engineering model of whatever you want to build. That's what the system engineering group does. Then after that, what happens? They move out, they design, they give you fantastic, whatever designs, whatever you want, and then they move out. Now, is it possible to realize it? Okay, somebody says like, you want a big optical bench with 1 micron surface roughness over 1 meter. Is it possible to realize that? So there's such kind of argument that goes on, okay? And ultimately we have a realization team. Of course, some of the SEG group also will be part of realization. And we start looking at who can sort of deliver us these kind of, who can meet these engineering challenges, industries, okay? Or other academic institutions. We look for that, and it's a very detailed process. We go through that, and then after you realize that you have to integrate and make sure that you calibrate that particular system. Whatever you are doing, the calibration itself is a major challenge. That's when the scientists move in over here to say that your instrument is giving my science data whatever I wanted in that format. What are the dark noise? What are the noise levels? Etc. Everything actually. And of course, then we have this enormous amount of data coming in. Okay. Enormous amount. So you need to have people who look at this data, analyze the data, and then come out with science products. So there's a lot of, and then also there are a lot of tools that we develop, automated data processing. That's when the computer science background people and all of them come in. And ultimately, we look at technology spin-offs. I mean, I'll give you a couple of examples as I proceed. I mean, we have got tremendous amount of technology spin-offs from most of these activities. And all of them, please remember one thing, there's no differentiation between research and engineering over here. They go in hand over here. In fact, engineering is much more than the research itself. I mean, academic people. But this engineering is nothing but, again, research. Yeah, next slide, please. Okay, now it's just a definition of astronomy. I mean, just to, probably I thought a lot of students will be there. What is most important in astronomy is to study everything in the universe. When you look up whatever you see or you don't see, study everything, okay? It encompasses everything from microscopic to macroscopic. It is to study the past, the present, and can we say something about future? Because we all have heard the future is expanding at an extremely rapid rate, okay? But what is it expanding to? What's going to happen to everything, okay? So these kind of questions. So if you can study the past, the present, and the future, with the predictive model for the future, so astronomy encompasses all of that, okay? And of course, as I said, smallest particles, because the space is nothing but, even though night times we go to some hill station, look up the skies, and we sort of feel very elated and we feel very happy. We plug the stars and any number of poetic feelings and spiritual feelings and these kind of things. But when it comes to hardcore astronomy, you realize space is nothing but full of junk and muck. Okay, it's extremely difficult to survive over there for any of us, for that matter. We should be really, really lucky to have our, atmosphere, which cleans up all this muck and makes all of us leave. Of course, unfortunately, we don't realize that. We spoil it more and more. And again, there's nothing like, it's sort of every science is there, because see, you have astronomy, you have astrochemistry, astrobiology, you have, name it, you have all of that. It's completely interdisciplinary, because astrobiology is to look for life elsewhere, okay? Or when did the life start, what forms it was earlier, and how is it evolving, where will it evolve to? So these are all the questions that comes to that. Astrochemistry, the chemical composition of, stars, planets, all of that, and our own sun for that matter. It's a major object of study, okay? So that's what is astronomy. Next one, please. Okay. This is, I'm sure many of you would have seen in several science, journals or magazines. Typically, this is centered around the Big Bang theory, and where we say this is basically a WMAP image. Basically, it's a measure of cosmic microwave background. It's a mission called WMAP. Basically, measurement of anisotropy in the universe for this cosmic microwave background. Okay? That's the probe, and with that we came out with what is famous bell curve, and which which we talk about. We try to give an age for this particular universe. It's about 14 billion, maybe 13.7, 14, those kind of numbers. Don't worry too much about the numbers over there. And typically the arrival of Homo sapiens, that is all of us, is about 200,000 years ago, and then of course various other aspects. Now this is actually, if you look at every dot over there, it would be millions and trillions of galaxies. Okay, that's the kind of universe we live in. Next slide, please. Okay, now this is one slide to show that how few we are in the universe. Okay, I mean, let me not go too much into definition of dark matter and dark energy. Okay, they are very interesting topics. What is most important is the baryonic matter in the universe is about less than 4%. Baryonic matter is nothing but free atoms. Okay, and in that also what we call heavy elements, that is like planets and stars and things like that. Stars are about 0.5%, and other more heavy elements which form these planets and asteroids and various things, it's only 0.03%. It's only 0.0. Please remember that how spread out the whole universe is. How it's not dense. It's actually really spread out universe. And then of course the stars. What we think, the stars themselves, we don't know how many. See, for example, our own Milky Way, okay, has 10 power 12 stars, and Sun is one of the small stars. Our own Sun. So this is a number. There are trillions and trillions of Milky Ways, much bigger than our own Milky Way. So what do we feel now? That's the kind of universe we live in, and our own numbers are so very small over there. Okay? All right, next slide, please. So that's what actually, astronomy drives some of these things, trying to understand these things. All right, dark matter, dark energy, what the universe is composing of, and a lot of these questions come in. And again, as I said, we need to have some tool to study. That's the light. Okay, light or photon. It covers entire electromagnetic spectrum we can think of, whatever we know now. Starting from extremely energetic X-rays or gamma rays to going to far infrared domains. Okay, and so every light photon, as I said, light is a cosmic messenger for us. And in astronomy, every photon matters. Okay? You just think about it, because I focus my telescope on a particular object, okay, in a very distant object, what we call deep space studies, and then I want to collect every photon that will give me, because light travels at a certain speed. Okay, so using certain scientific tools like Doppler shifts and various things, I finally say that what is the origin of this particular light, and looking at the frequency shifts, what would be the age of the star and kind of thing. There are a lot of such things actually. That's why light matters over here. Light matters starting from visible to entire electromagnetic spectrum. Okay, that's the effort in terms of what I call engineering astronomy. Yeah, next slide, please. Okay, this is again, there are two types. I'll not spend too much time on this. Is ground-based and space-based. Okay, and also the theoretical teams, groups, and simulation groups, and etc. Next slide, please. Okay, telescope is again, of course, it's more of a definition. All of us know what a telescope is. I mean, every one of us would have used binocular at least sometime or other in our lives. Okay, so basically, it is like an instrument. Telescope is an instrument already. There are a lot of back-end instruments, science instruments. They are also part of the whole notion called telescope over here. I'm just trying to sort of, the back-end instruments itself can be more complex than the telescope itself. Okay. Next slide, please. Okay, now why do we need big size? Why do you see, now if you have seen in the papers or even, Raghavendra Prasad website and things like that, you see that, we are looking for real large telescopes. Okay. And why do we need that? Okay. The simple example I'm trying to give you is that you look at Jupiter with a 2-inch simple binocular, and look at Jupiter with 8-inch small telescope, reflector telescope or something like that, and look at it with a larger telescope, a 2-meter class telescope. You see the fine features you are able to look at the Jupiter itself, on Jupiter. Okay. So basically, the larger the telescope, you can look at distant objects, more light gathering. So these are all advantages. But the engineering complexity increases exponentially. Even though telescope size might increase linearly, I may say, from 1 meter to 2 meter, 2 meter to 3 meters. Believe it or not, this complexity is not linear anymore over there. It is exponential. Okay, so that's the engineering challenges we face over there. Next one, please. Yeah. Of course, it's very important to ensure that your telescope is in some location where humans don't pollute the environment. And even my own institute, wherever we set up telescopes earlier, now you find that human population have moved in, and those telescope, the observations have become very bad actually. So we moved to Himalayas deep in Ladakh region and started setting up observatories over there also. And so these are the human what I would say pollution, light pollution and weather pollution and various things that really affect your seeing. So we try to go to remote spaces, or we go into space. Okay, this is the thing. Okay, next one. Okay, this is our IAS observatory, what's called the Himalayan Chandra telescope at Hanley. It's about 4,500 meters above the sea level, mean sea level. It's one of the very good sites for astronomy purpose, and then where you don't find anybody for many kilometers, no human settlement. Of course, now you have a lot of defense establishments coming over there because of various other geopolitical issues. But otherwise, it's one of those most pristine sites where out of 365 days, you have at least about 300 clear nights, what we call that. And I urge, if any of you go towards Ladakh or something like that, please visit this site. And if any of you can write to me also, I enables this what's called astro-tourism. Okay, students and faculty, anybody who want to go, they can go there. They can really feel, the kind of nature that we need to preserve to do good science. Okay, next one, please. Okay. Now, actually, we are now going into real large telescopes. See, we have 2 meter class, we have 4 meter class, 6 meter class telescope, but that is still not meeting the human hunger for understanding more, seeing more. Okay, to understand ourselves, understand the nature, and understand everything around us. So there are 3 mega projects world over. One is Giant Magellan Telescope. Okay. And the other one is what's called 30-meter telescope led by University of California, and also Caltech, and the European Extra Large Telescope. And India is a partner with 30-meter telescope. Some of the sizes are given. Let's not go into too much of that. Now, this 30-meter telescope, where India's contribution is more than almost about 3,000 crores, is a 10% partnership. So you can scale it up in terms of what would be the total cost of the telescope. That is only to build the telescope and install it and some of the back-end instruments. And then operational costs, that's a different thing. Now, for this, next slide, please. Okay, this is an illustration of the, how it would look once it is, realized. Basically, it's about 30 meters, the primary mirror, what we call. And light collection area is about 655 square meters. So you can look at stars which are magnitude of extremely low magnitude stars. Okay, that means extremely faint stars. Okay, the magnitude is a number we use over here. And once this telescope is operational, now we know this Hubble telescope has given us extraordinary information, but this will give much more information than Hubble itself. Okay, and Hubble, of course, its life is going to get end pretty soon once we launch, because James Webb is going to be functional soon. So that's the thing. And why, I'll tell you why the difference also comes. Why do we need to go to space, and what are other challenges over there? Next slide, please. Okay, this is basically to show that different, the telescope dome, what we call, will be almost about 100 meters, okay, with by accommodating all the back-end instruments, and such a huge engineering challenge over here. There are, what's called, in IAA we have a 30-meter telescope, India TMT Coordination Center. I know how these people work, and I myself worked on this program for quite some time before I moved to some other program, and it's a real challenge. Okay, next slide, please. Okay, see, what happened was that our logic was that we are not going to give you just money. Okay, we are not going to transfer 3,000 crores and hold our hands and sit and then wait for the data to come. No, we want to develop most of the subsystems, that to most complex subsystems. Okay, not every unwanted subsystem over there. And I'm not saying unwanted, easy to realize kind of subsystems in India. We wanted most complex subsystems to be realized, which are real engineering challenge. I will give you one example. In IAA, we are setting up now. This will have what, as I said, about 500 mirrors, co-faced mirrors. Okay, it's all 1.4 meter hexagonal segments, and IAA has set up a fabrication facility, to realize this mirror technology is again the most important technology. Okay, we need to own that. And then the second one is this segment support assemblies. We require about 500 or 600 of them, 500 to be put in and 100 spare. Now we work with a lot of industries like L&T, Godrej, Walchennagar, okay, several of them, okay, to developing the prototypes. Believe it or not, even such big industries, such engineering might, they have taken more than 5 years to build what is called prototype. Now we have come again, in the sense there are a lot of quality issues there. We are trying to argue with them and trying to improve them. And finally, we want to give each of them some 100 segments like that. We don't want to give in one place. So that's the, it's sort of employed so many people, so many, engineers who are in gained from this expertise. And there are many more things. And of course, India is a, software powerhouse. I just spent one extra slide on that, software developments also. And you can see one image of an instrument over here. This is what WFOSC, okay, faint object spectrograph. See the size of the telescope relative to the instrument spectrograph. There are two humans standing over there. Can you see that? So that's the size of the back-end instrument itself is going to be many of them. And the other one is the most complex adaptive optics, which my team, my students have been working on. The next one, please. Okay, this is the software. Just I'm sure all of you are experts. You will know more about it than me. Just to say that all those that's colored shaded in red are India's contribution. Where we have, just to give you this one, it has about 30,000 input-output channels and 12,000 degrees of freedom. Okay, and this entire thing has to take care of telescope control and instrument control, adaptive optics control, every one of them. Okay? So that's the level of software complexity that we have been working with several IT industries in the country, and in a modular fashion. And then we need to put it together. So we have a big team working on that. Next one, please. Okay. So when you're spending so much on ground, why do you want to go to space? Okay. What is that we are going to get out of that? You must have heard of various space missions, which have contributed, even though the life cycles are much smaller, the kind of data they have given us are enormous, okay? And the challenges of sending a telescope in space itself, it's much more complex than if I want to put, say, even 500 mm telescope into space, okay? The complexes are much larger than ground-based, even 8-meter class telescope. Now, we want actually, see, when we have a telescope on Earth, all of us know that, because of our, actual going around this, and we have day and night and cycles and things, various things, so we cannot get uninterrupted view of the sky itself. So we want to do all that, and Earth's atmosphere itself is a major spoiler for us over here. You see a star image over there, and you see the distorted image by the time you see. There's no correlation between those two, okay? Even though we have very complex closed cycle adaptive optics, what we call, where the mirrors themselves get deformed and then try to adjust and, and try to get you the good image, but still it doesn't give you the actual image, what the original, what the star is actually is. And of course, Earth's air glow, and those can be avoided. And the other one is this, you see the Earth's atmospheric opacity, okay? The opacity is such that there are very few spectral regions where you have telescopes on Earth, particularly in a visible thing. The moment you go into infrared and and also the high energetic things, and they don't get transmitted to Earth's atmosphere, so you need to go into space, and that's where the more physics is. Okay, that's why we go into space telescopes. The next one, please. Okay, now the challenges here is again space environment. Okay, and space is whatever you send there can get damaged in no time. So it has to be what is called, it has to stand the radiation, hardened, subsystems, even electronics. See, the moment you say that I want a space qualified chip, be assured that if that chip costs for the normal application 100 rupees, that will cost you about 1,000 times more. Radiation hardened chip. So there is, you know very well that standard grade, mill grade, and space grades and things that. So that very difficult to get them also. And of course, extreme temperatures. It goes into real, what I would say is minus 20, minus 30 degrees Celsius. And then of course, design, again space, if you do not design, there's no scope for failure. If it fails, it fails. Like for example, our Chandrayaan mission, the lander. It's a very classic example. Recently we had that couple of unfortunate failure it was. Even though it went through various laboratory tests and models, finally one of the thrusters not firing properly, okay, and miscalculations over there, it crashed, okay. So that's why, once it crashes, it's gone. There's nothing you can do about it. It's not like, in the ground you can go take a spanner or do something and, tinker it and come and say it's working. No, in space, no. Once it fails, fails. So for that, we have what's called space qualification methodologies themselves. See, for simple, when the launch vehicle takes off, the kind of launch loads could be even a 50 times the gravitational force. So whatever you design, you need to qualify it 3 times that number, depending on the location of it. So we have to set up facilities where we qualify them through those kind of space environment, thermal, launch loads, various things, and radiation, measurement of radiation damage, etc. And model philosophy, if I want to send one binocular to space, I need to build 4 binoculars. Okay, in space, very well, we build what's called laboratory model. Post this design phase, we'll say whether it's feasible to do that. Okay, laboratory model, and basically it is more for estimating what we call mass real estate on the satellite, because satellites cannot be too big. They have, there's a lot of, every gram matters over there, every centimeter matters over there. So this is what we call as laboratory model, and take it through various, environmental test procedures and see if it stands over there. Then after, based on learnings from that, we build what's called engineering model, a qualification model. Again, that also goes through. After that, only you build what's called flight model. Now, flight model can also fail on the test table. So we have some flight space also in place. So believe it or not, once I send one Chandrayaan mission, I have 3 Chandrayaan payloads sitting on my ground. I don't know what to do afterwards. So that's the kind of work that goes into over there. Okay, and then of course, after that, in space power, real estate, data, downlink, because you need to have every downlink stations around the globe working for you, and data products. All these are the real challenges. Okay, the next one, please. Yeah. Okay, these are some of the very famous, science missions you see from far infrared to gamma rays, and some of them you can see Chandra mission and Hubble telescope, etc., 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 and which have given us, real. People are still analyzing the data, trying to understand them. Okay, the next one, please. Okay, we ourselves in IAA, about 20 years ago after I joined, Institute of Astrophysics, there was a policy decision to go into space. ISRO also was very keen on going to space science missions, basically the astronomy missions. So we set up a extraordinary, really high class, class 10 grade or ISO 5 standard clean rooms, and various other. Next slide, please. We call it as MGQ Laboratory for Space Sciences. And of course, recently we added some more facilities for space, environmental test facility, what we call it, and it was inaugurated by, Honorable Vice President, and you can see, Mr. Bommai, Chief Minister of Karnataka also being there. And then next one, please. These are some of the images. All of you, I'm sure, heard of this AstroSat mission, that Indian Astronomy satellite. And at Institute of Astrophysics, we built the prime payload, what's called UV-8, UV imaging telescope. Basically, we are trying to look at vacuum UV photons into up to visible domain. So next one, please. Yeah, this is basically the image of the satellite. Next one. And in my lab, we are trying to put things together. And then since it's a class 10, here again, I just want to tell you that it's not just a particulate count. Okay, it's a semiconductor grade clean room where molecular contamination becomes extremely critical for us. So we qualify every material that comes in there for its molecular contamination properties. Okay, if it doesn't meet our standards, we throw it out. Okay, so that we have all those protocols in place. Next one, please. Yeah, this is the the integration activity. You can see how complex this whole thing is. The next one. This again mounted on a what is called test bed. Next one, please. This is the integrated satellite as such. You can see all the payloads, and you can see the UV-80 over there. And next one. Yeah. Now next one. Now the most important thing, which where my head is on probably on a tight situation, is this Aditya mission to study our own sun. Aditya, and the spacecraft will go to Lagrange point. Again, see, when we want to do something, we want to do something which others have not done. Okay, that's the most important thing. Again, see, one can ask questions, what about they have done? What have they have done? NASA has done, ESA has done. But we need to convince our own selves, first of all, what we can contribute more uniquely than what others have not contributed, what others machines have not contributed. So like that we have several payloads, and our idea is to, I mean, all of you would know that we all sort of imagine that the solar disk, what we see in a early morning or evening or even, you know, it's the hottest thing. Our sun is the hottest thing. No, that is not. The solar outer atmosphere, what we call corona, is almost about 2 to 3 million times more than temperature is more than that of even the surface, the sun surface itself, what we call photosphere. Now, why is it so? The origin itself is cool, and outer atmosphere is so hot. So what's happening? What are the dynamics? Okay, and why is it important to study? Because it throws off what's called, the solar wind, solar muck, which damages all our space assets. Recently, you would have seen in paper that Starlink 40 satellites got deorbited because there was a solar storm. So now we are trying to do with this. So far, there's no predictive model for the solar storms. Okay, that's one thing. The second one is that there are no study so close to the solar limb where the actual physics is. Okay, the actual solar, what we call coronal CME, coronal mass ejections, which gives rise to the solar storms. So we are trying to go as close to the solar disk itself. So far, no other mission is there. Now, that problem there is, how do we realize that? Next slide, please. Of course, we go through a lot of, I will not go too much, and I'm sure I'm running out of time. This is the satellite, how it looks once it's, completely integrated. You can see the primary payload, that visible emission line coronagraph, which IEA is building, and I'm sort of responsible for that. And there are multi-institutions involved over here. Next one, please. Yeah, this I will not go too much into details. See, the other one is other technology. What we are looking at is so far all our satellites, what we call pointing accuracy or pointing stabilities were few arc minutes. Okay. Now with this mission, we are trying to go 10 arc second is a pointing accuracy we are trying to look at. And so ISRO and ourselves, we are working, very iteratively to get those kind of pointing accuracy. Another greatest spin-off that can come from here. And some of the mirrors over here, once we master the technology, engineering, if the production master is there, then every satellite, you can read the, number plate on even a two-wheeler from space. So that's the kind of resolution we get over there. Next one, please. Yeah, this is a very complex, I will not go too much into details of this layout of this payload. You can see it's a nightmarish actually. Right now, we are doing the integration activities. Next one. Yeah, this is basically to what I said, the environmental test, extreme low temperatures. We take our, some of the systems up to minus 200 and then see if it survives and do tests and see if it performs. Okay, next one. And okay, one more thing I just want to see, this is basically is getting integrated, and what you see as a dark flat surface, it is, made of titanium, and the size is about 1.7 meters by 1.2 meters, okay? And the thickness is about 75 millimeters. Now, I'm sure anybody can guess what would be its total weight to start with, okay? It's a monolithic titanium block. When we got it from Midani was the only company which supplied to us, it's about almost 1 ton, okay? Almost about 1 ton. Now, the machining of this particular thing, after machining and maintaining, because for us, what is important is the stiffness of the bench, okay? So it was real nightmarish challenge for, no company was willing to do that. Ultimately, BrahMos took it as a challenge to machine it to the level we want. And as Jagdish mentioned one of his talks, like, surface micro roughness or surface finish, it's about 20 micron over the entire length. And the current final finished mass, okay, of the same size, same thickness, everything is less than 40 kilos. So it has taken 3 years for BrahMos, with lot of iteration with us, to realize this. So these are the challenges. These are engineering challenges where many of the mechanical engineers, I'm sorry that people are really not going into mechanical engineering now, It's really, I mean, every element over there was, is a nightmare in terms of mechanical design plus realization, okay? So that's the level of complexity that gets into all these things. So that's why engineers do matter everywhere. Okay, next one, please. Okay, now again the software, see, this payload churns out about 3 terabytes of data per day. Because you are looking at sun 24 hours, 365 days, continuously over the mission life, okay? 3 terabytes, I'm sure all of you, all the computer science professionals will know how nightmarish it is to handle that. And these data which comes down has a lot of muck. And this, remember one thing, this satellite is sitting about 1.5 million kilometers away from sun, from Earth. to what's called Lagrange point 1. It's basically, it's a, a gravitational equilibrium position between Sun-Earth orbit, where the satellite is much more stable. I mean, this is basically mechanically is a three-body problem mathematically, and a more stable orbit for solar mission. So there are a lot of launch calculations that go into that to insert the satellite, the transition period, interorbital transition. So we work very closely with the mission team. Of course, first thing they say, it's not possible. Okay, that's how it starts. And you argue, fight, solve the equations, simulate it, then show it is possible. So like that, it goes on. I mean, it's like almost like every day you are having some call and say, almost, if you're face to face, you'll have probably end up with some physical damages. But it's very interesting actually, because everybody is right over there. Everybody is passionate about it. Okay, and even though out of frustration, they're still successful. That's how we are very successful in many of these very complex missions. That is because the engineering community, why I'm saying engineering community, I'm not giving too much importance to science, even though I'm a science background person, is that if they are not there, none of these things we can talk about. Okay, and then with these technologies, we have got several, so I was just telling Jagdish in the morning when we were coming, we have been able to, some of this technology, we have been able to develop some multimodal microscopes and angiobiograms and, for mass screening of diseases, and then small angle gamma ray camera. Okay, it's a mechanical structure design of that. So there's a lot of spin-offs we are looking at parallelly, okay? So that we are not in a cocoon where we do not know outside world. No, that's not. So we work with a lot of colleges and, universities. Whosoever is interested, they can come to us. We work with them, okay? Next one, please, yeah. And of course, this is the last slide of mine. It's a James Webb telescope. Just to give you some statistics, it's about, it's almost about, it has taken 30 years to develop this from concept to completion. Now it is reached its, what we call parking place in Lagrange point 2, which is for deep space studies. And of course, cost is anybody's guess. And then, but the information what we are going to get, if it really works, okay, I think it will change our understanding of the universe in a totally different way. And we are trying to study our own sun and see what we can do with it. And this is going to look at the entire deep space and see what we can get out of that. And it's right now it's operational now. They've already taken some images of the first formation stars. Can you imagine? That's about 4 billion years ago. Okay, they have collected photons from those stars now. Okay, recently there was a small report on that. So it is getting warmed up, and then all of these systems are going to be complementary to each other, ground-based, space-based, every one of them. They're not unique, they're not standalone, please remember that. Astronomers require data from each and every one of this mission to come out with something meaningful. So that's what is astronomy, and that's what the engineering is all about in astronomy. Next one, please. Yeah, this is basically this is taken from our own Government of India Vigyan Prasad website. Again, this is a famous bell curve, and then you see the number of major missions, both ground-based and space-based, in astronomy missions, which India is now investing enormously into. Okay, so these are all including, now recently even LIGO got approved. Okay, gravitational wave measurement experiments also, and you see 30-meter telescope over this, like that, and you see those wherever they are marked, they show the different age, information or different formative periods of the universe itself. Okay, yeah. Thank you. I'm sure I've taken more than my allotted time. I'm sorry for that. Yeah.
thank you, sir, Professor Dr. Raghavendra, sir, for emphasizing on engineering challenges in astronomy, approaches to astronomy, universe composition, importance of telescope and telescope control software. So now, ladies and gentlemen, it's the time to present the awards. May I now request Dr. K.V. Suresh, Professor, Department of Electronics Communication Engineering, to take us through the awards presentation ceremony.
Good afternoon, everybody. I am happy to take you through the award presentation ceremony now. Hearty congratulations to all the award winners and their respective guides. May I request our Chief Guest Dr. Raghvendra Prasad to present the awards. To begin with, I call upon Dr. Annappa, who will be receiving the Best PhD Thesis Award of his student in this. The student's name is Dr. Kirti Srinivas Sethi, IIIT Hyderabad. Next, I call upon Dr. Puneet Kumar TR, SIT TUMKUR, who is receiving his award in ECE category. Yes, sir. ಹೇಳಿದೆ ಸರ್ SIT. Dr. Krishnamurthy in this grade. Okay. Now, presentation of a special mention of the jury award. I call upon Dr. Samina Begum Pradhan, MIT Mahe Manipal, under CSE category. Thank you, sir. Now I request Dr. Jagdish sir to present the awards. Dr. Rupa S. SIT TUMKUR, she receives a special mention of the jury award in ECE category. Thank you, sir. I request Dr. K.N.B. Murthy sir to present special mention of the jury award to Dr. Grenil Joktan, NMAT NITE from other branches. Behind every successful PhD student, there is always a guide's effort. Now it is time for us to give awards to the respective guides. I request our beloved director, Dr. M.N. Chandra, to hand over the award. Dr. Annappa from NITK Surathkal. Thank you, sir. I request our beloved CEO, Dr. Sivakumara sir, to present the award to Dr. Krishnamurthy K, NITK Surathkal. Thank you, sir. I request our principal, Dr. Dinesh sir, to give presentation to Dr. P.C. Siddaganga Swami, MIT Mahe, Manipal. Thank you, sir. I once again request Dr. Raghvendra Prasad to give presentation to, okay, Dr. Sham. No, sir. Dr. Narsimhan SV, and in his absence, Dr. Rupa S. Will be receiving the award. Dr. Srinivas Pai P. NMIT NITI. Now presentation of mementos to the jury members. I request Dr. K.N.B. Murthy to give the presentations. Professor G. Jagadish, Chairman. Professor Shyam Vasudeva Rao, Member. Dr. S.S. Katte, Technology Support. Now, presentation of memento to the chief guest, Dr. Raghvendra Prasad. I request Dr. K.N.B. Murthy sir to present. Presentation of memento to Dr. M.N. Channabasappa sir. I request Dr. K.N.B. Murthy sir to give the presentation. Thank you, sir. Thank you.
Thank you, sir. Let's mark the end of the ceremony with a vote of thanks, appreciation, and gratitude to everyone who made this event a grand success. Now I request Dr. D.N. Sujata, Executive Director, BITES, to propose vote of thanks.
Thank you, Madam. My humble pranams to the Gurus of Sree Siddaganga Mutt. Good afternoon to all of you, dignitaries on the dais of the dais. I am honored to present vote of thanks on the occasion of BITES Best PhD Thesis Ceremony 2020. At the outset, BITES congratulates all the awardees and the research supervisor for all the interest they have shown in the research. Congratulations to all of you and best wishes for all your future endeavors. BITES would like to thank Dr. Raghavendra Prasad B, Senior Professor with Indian Institute of Astrophysics, Bangalore, for spending his valuable time and sharing insightful thoughts with all of us today. Thank you so much, sir. BITES acknowledges the gracious presence and blessings of Professor M.N. Channabasappa sir for all his support as always. You are a constant source of inspiration to all of us, sir. And generally ahead of time, so if you are a minute late, you feel really very awkward. There's a lot of learning from Professor as always. We acknowledge and appreciate the time and efforts of the evaluation committee led by Professor Jagdish, Chairman, Center of Excellence in Hypersonics, and Professor in the Department of Aerodynamics at Indian Institute of Science. Thank you, sir, for sharing the evaluation process and instilling a lot of research inspiration to all of the fellow faculty members of the research community. Your talk was truly inspiring and lively as always, sir. Thank you for it. The evaluation committee included Dr. Shyam Vasudev Rao, Dr. Punita, and Dr. Prakash Raghavendra as its members. We have Dr. Shyam with us today. Thank you so much, sir, for gracing the occasion. BITES appreciates and acknowledges the support of SIT TUMKUR for hosting the award ceremony. We express our sincere gratitude to the management, specifically Professor Channabasappa sir, Professor Sivakumara sir, Professor Dinesh, and Professor Suresh. They have been seamlessly supporting us in coordinating with this fantastic activity today. Thank you for it. And a big round of applause to SIT for being an amazing host today for this particular event, as always. BITES acknowledges the technical support of Professor Katti. Thank you, Sivakumara sir. Thank you, Dinesh sir. Professor Suresh sir for seamlessly coordinating and make sure that this event is truly successful. BITES acknowledge the technical support of Professor Subramanya Katte, who is the professor in Dayanand Sagara University. We would like to thank Dr. K.N. Murthy sir for steering this event, and Mr. M.N. Vidyashankar, who is the co-chairman. He is not with us today, but he could not be physically present, so he has sent us greetings and hearty congratulations to all the awardees and the research supervisors. We would like to thank Mr. Krishnaswamy Subbarao of Infosys, who is one of our governing board members. Thank you for your presence today, sir. We also acknowledge the constant support of all the board members of BITES. Thank you, Krishnaswamy Subbarao, sir. Thank you. BITES acknowledge the support received from Mrs. Jyoti, the program officer, who has been coordinating with SIT for this particular event. Thank you, ma'am. So finally, BITES would like to thank all the member institutions for sending us the nomination for this BITES Best PhD Thesis Award 2020, and they have been actively participating in all the activities of BITES. So our sincere thanks to all the member institutions for encouraging the activities of BITES. Thanking all those who have been indirectly or directly contributing for all the activities of BITES. I know I'm standing between you and lunch, so have a happy, delicious lunch at SIT as always. Thank you so much.
Thank you, madam, for coordinating this activity truly successful today. Yeah. So finally, I would like to thank BITES for providing an opportunity to host this ceremony at our institute. And also, I would like to thank Ms. Srimati Jyoti, Program Officer, BITES, for continuously coordinating and communicating with Dr. K.V. Suresh in organizing this event. And also, I take this opportunity to thank K.V. Suresh, Professor K.V. Suresh, Department of EC, for meticulously planning and organizing this event at SIT. Thank you one and all. Yeah, all are requested to join for lunch and at Alumni Guest House. Thank you. I request all the awardees to come near to the dais to take a group photo, please.